In traditional OOP languages, a class can be derived from another class. This class is usually called a subclass of its superclass. And the subclass inherits all properties and methods of the superclass that it is derived from. This is the mechanism of inheritance in traditional OOP languages. With the class construct in JavaScript, we can also create a subclass. Let me give an example that fits with our meeting room class. Let's say we have a bunch of different types of rooms we want to deal with. And the features are different enough that we want a different class for, say, meeting rooms, break rooms, and perhaps meeting pods. However, they all have some things in common. So it makes sense to create a rooms class and then create 3 subclasses: meeting room, break room, and meeting pod. These subclasses would inherit from the rooms class. This type of structure is very common in traditional OOP. However, in the past, it has been a bit difficult to achieve in JavaScript. But with the class construct, we are now able to subclass another class. Let's take a look at that. So first thing we want to do is, instead of making this the meeting room class, we're going to make it the room class, like that. Everything else in here can stay the same because that part will not change. And then we're going to come down here, adding this to the prototype, so we'll change that to room as well. And then let's go ahead and just set up the subclasses here. Now, the keyword we use to do that in JavaScript is extends. So the way we would create it is we do class. So we're still declaring a class, and we're going to call it meeting room, like that. But it extends the room class, the one we've created up here. It's going to extend that. So by using the extends keyword, now this class, any instance that is created from this class will have everything that's a part of the room class unless it's overwritten in this subclass. All right, so let's go ahead and just see what happens if we subclass several of these, make several subclasses, and then we'll create some instances of it without putting anything else in those subclasses. So now I'm going to do the break room, and that extends room as well. So we're using the exact same construct there and the extends keyword. And now finally we'll do meeting pod. So this is a class as well, meeting pod, and it extends room. So just like that. Now we have these subclasses set up. We want to create some instances of them. So for boardroom and training room A, we can leave these as they are. We're creating them from the meeting room class, which we have up here. There's nothing in it now because we extend the room class. Let's add a few more. Let's add one for lunchroom. Lunchroom A, and we're going to create a new break room. So an instance of the break room class. Let's go ahead and pass in name here and also capacity of 200. All right, and now we'll also do a pod, a meeting pod. We'll call it pod 201 after perhaps its location on the second floor or something like that, but we will create a new meeting pod. And once again, we're going to pass in a name and a capacity. All right, so we've got 4 instances set up now. Let's just take a look at them. So if I save this, got the server running here. I'm going to jump out. Let's take a look at the console, and we'll look at boardroom first. This is one we've looked at in the past, and notice it has all the same things on it. And we can still access the method that is on its superclass. Okay, so now if we look at boardroom, we should have We have a schedule in there. We've added an object to the schedule in that array there. Let's look at another one. Let's look at pod 201. This is a new one. And we can see everything is available there as well. So we've subclassed, we've made subclasses. We have the room class up at the top, and then we've extended it to make 3 additional classes, and these are subclasses of the room class. Now let's expand on this a bit. So let's look at the meeting pods for just a minute. Now let's say that meeting pods always only have a capacity of 1. They're just little tiny rooms where people can step in to make a phone call or something like that, or meet virtually. And so they always have a capacity of 1. So it makes no sense for us to have to pass that in every time. So we want to set it up so meeting pod can be done this way. Well, right now that's pretty easy to do. We can come up to our constructor method inside of the room class, and since this is extended, we can just put a default value for capacity. So if a value is passed in for capacity, it will use that. If 1 is not, it will use the default value of 1, and that takes care of it for us. So now we don't have to pass in a capacity when we're creating a meeting pod. So that simplifies things a little bit for us. Let's just, before we're going to do some more with this meeting pod, but before we do that, let's just take a look at that. Let's look at pod 201. We're still getting a capacity. Let's also look at boardroom. Whoops. And we're still getting a capacity of 20 there. So that's working for us. All right. Now, our meeting pods may or may not have a phone. So sometimes those meeting pods will have a phone. Sometimes they're just for virtual meetings and they don't have a phone. And we want to keep track of that here in our meeting pod class. So let's go ahead and deal with that now. So we're going to create a constructor in here because we want to add more things. So in this constructor, we need to receive a name. That's being passed in down here. But also, we now want to be able to pass in whether there's a phone or not, like true. This one happens to have a phone. And so we're going to grab that with a new variable here in the constructor, phone. Now, what do we do at this point? We're receiving the name here, but the name is assigned using the superclass up here. That's where the name gets assigned. So what do? Well, the first thing you need to do in a constructor that is extending, that's in a subclass, is extending another class, you must call that constructor using the keyword super. And that's what super does. So we're going to call a constructor of the superclass, and we're going to pass the name variable up there. Now we need to do that before we use the keyword this here in this constructor. We're now going to use keyword this to assign phone the value that's passed in. Now remember, this is an important rule. You must do this, or you must call super before you do this. Even if you don't pass anything up to the superclass constructor, you need to call it before you use the keyword this. All right, we have our constructor set up that will allow us to assign a phone, whether a phone or not is available in that meeting pod. Now, one more thing that I want to add to this meeting pod. Let's assume that they can only be scheduled for 30 minutes. Never any other time other than 30 minutes. When they're scheduled, they're a 30-minute block, and that's what they are. So that is handled by our reserve method. Well, we need to make our reserve method a little bit different for the meeting pod. So what pillar of OOP is this that we're going to be using? This is polymorphism. In meeting pods, the reserve method is going to act a bit different. So let me go ahead and put that in. So right now, I'm entering a reserve method here. It's going to accept a date object like before. But that's all. We don't need to accept a length because the length is always 30 for a meeting pod. And so when a meeting pod uses the reserve method, it's going to use this one here instead of the one in the superclass. Okay, so that's how this is handled. And we'll take a look at how that is handled in the prototype in just a minute. But let me finish setting this up. So this dot schedule, we do it basically the same way, dot push, and we're going to pass in an object, whoops, with the date and a length of 30 like this, okay? And that will take care of the reserve method there. So we're showing polymorphism here. All right, let's go ahead and save that and make sure this is working for us. So if we have a boardroom and we want to reserve like we've done, whoops, like we've done in the past, let's go ahead and do that one there. And then let's take a look at boardroom, make sure that is still working. Make sure the reserve method is. So we look at the schedule here and we're seeing that it's got an object in there, a length of 60. So that works for us, that's still working. Now, if we want to do our meeting pod, and we do pod 201.reserve, whoops. Let's do this one. And let's just do today's date, just to make this simple so we're not typing a lot here. Now, we press return. Let's go ahead and take a look at that. All right, we've got something in the array schedule. We can see that there. So if we open that up, and we have it sitting there, and it has a length of 30. It went ahead and did that for us. So it used the reserve method that is on the meeting pod class instead of the one that's on the room class. And notice also we have the phone property here set to true. Now let's go ahead and take a look at the prototype and see how this is handled. So here's our prototype. And notice we have a reserve method. And this is the one that only has one parameter, and that's the date object, all right? Now, if we continue up the prototype chain, we now see the other prototype where the reserve method is that has the length. And this also has the company, ABC Co-op. So we would still be able to grab that from a meeting pod because it's on the prototype chain. So here we're setting up these inheritance chains, these prototype chains, by using subclassing in JavaScript. And that's an important thing to realize. We're still using the prototypal inheritance. That is still what JavaScript uses. But many people think it's a simpler way to set all that up and set up those prototype chains using this class and subclass. All right, let's do one more bit of changes here. Actually, do two more bit of changes here. I'm going to modify the break room. I want to do another constructor here. So we're going to have one that doesn't modify at all. We could, but right now we're not going to. So I'm going to put a constructor here in the break room, and the break room just has more information we need to keep track of. So it has the name and it has the capacity. Those two things come in, but we also want to know if the break room has a kitchen and how many tables it has. So this would be a Boolean, and then this would be a number here. All right, so how do we handle that? Remember, the rule is we need to call super first, pass the name, pass the capacity. That will set that up for us. And now we can use the keyword this dot kitchen equals kitchen. And then this dot tables equal tables, like that. So we've got that constructor set up for our break room. Now let's go ahead and modify our call down here. We have two things being passed in. Lunchroom A does have a kitchen, so true there. And there are 10 tables. All right. So now we can take a look at that. Look at lunchroom A. Let's see what we got. All right, we have a capacity of 200. It has a kitchen. Available is true. Tables 10. So we now have those things showing up on our lunchroom. So you can see what subclassing can do for us here. Now, if we wanted to add another method and we wanted it to show up on all of the room types all of the subclasses, well, then we'd go ahead and add that method into the room class. And so let's take a look at that really quick. This, I think, is an important point as well. So down here before reserve, I'm just going to create a get info class or method like this. And what are we going to do with this? It's simply going to return some information. So we're going to set up a template string to do this. So use those back quotes there, and then name we're going to pass, or we're going to return the name first. And so we want to grab that. That will be on this.name, and that will be true for any of the instances that are created from all of the subclasses. And then also we want to display capacity if it has it. So let's look at that. So if there is a capacity, let's go ahead and do something like this. This.capacity, if that's greater than 1, so meaning there is a capacity, then we'll want to display it. So basically for meeting pods, we wouldn't display it. We're using the ternary operator here. And then what we're going to return is space hyphen and then capacity colon, whoops, single quote, and then add this.capacity. Okay. And then finish off our ternary operator here with a colon, and what do we return otherwise? Nothing. All right. And then finally, let's just display some information about it being available or not. Like this. And once more, we're going to use some information from the instance, from the object, this dot available, like that. So we'll just return that when we do get info. All right, let's see if that works for us. We added that to the superclass, to room. So let's go ahead and save that. Let's take a look at boardroom.getInfo. It returned information. Let's also take a look at pod201.getInfo. There we go. We're getting information back. Notice capacity is left off here for the pod. All right, so we've done quite a bit here. We've covered classes quite a bit. We've been abstracting away the details with the methods. We don't know how, for example, the getInfo method, we don't know exactly what it does to do this or this. We've extracted that away. We've been encapsulating data and methods in the instances of these classes and the actual objects that are created. We use polymorphism to make the reserve method act differently for meeting pods. We saw that in this particular movie. And then finally, we've used inheritance. Now, prototypal inheritance is how JavaScript works. But in writing out our code with the syntactic sugar that's the class construct provides, it allows us to order and create this inheritance in what many consider to be a more logical way. So we've got a good look into creating classes and subclassing. So, all right, let's move on to the next topic.